Discuss today elimination reaction. In this, two pathways are followed. First, we will discuss E2 elimination. In E2 elimination, what happens is we get a transition state. Only a transition state is formed. Let's consider this reaction. Alkyl halide react with base in suitable solvent. Like here, we have taken methanol. What happens is this base will abstract proton from beta carbon. This is alpha carbon, this is beta carbon, this is also beta carbon. So alpha beta elimination occur, that is dehydrohalogenation occur. D means removal, hydro stands for hydrogen, and halogenation, halogen is your chlorine, bromine or iodine, right? So bromine and hydrogen gets removed. So base abstracts a proton and this halogen gets removed, leading to formation of alkene. So if elimination occurs from this carbon, then this product is obtained, and if hydrogen gets removed from this carbon, then this product is obtained. So in this case, major product is this one, as we can see. Let's consider the mechanism. In this we can see the base will abstract the proton. Simultaneously the electron density will shift between these carbon bonds and the halogen gets removed. So transition state is formed in which bond is formed between base and hydrogen, and bond is break between carbon and hydrogen. Bond is formed between these two carbon atoms, another bond, pi bond, and this carbon halogen bond gets break. So in this state, bond making and bond breaking occur simultaneously, leading to formation of alkene. So because this is a one-step process, therefore rate law include both the reactants, that is your alkyl halide as well as the base. Like in this reaction, methoxide is the base. So because two species are involved in this, hence this reaction is a bimolecular reaction. So let us consider which hydrogen will be preferred, which beta hydrogen will be preferred. So if this beta hydrogen is involved, then this transition state is formed, and if this beta hydrogen is involved, then this transition state is formed. As we can say that the transition state has a double bond character, therefore greater the number of alpha hydrogen, more is the stability. This is because of hyperconjugation. The stability of alkenes is determined by hyperconjugation. So this transition state is more stable because it has 6 alpha hydrogen, while this transition state is less stable because it has only 2 alpha hydrogen, as we can see. Therefore, the reactivity order is 3 degree greater than 2 degree greater than 1 degree. It is simply because greater the stability of transition state due to hyperconjugation, easier is the product formation. So we can also see that the major product is obtained according to Sedgwick's rule. So what is Sedgwick's rule? More substituted alkene is the major product. Right, so as we can see here, we have two alkyl groups. So this is more substituted, while in this is the alkyl group. Ethyl is the only alkyl group, so it is less stable. The product obtained hence is according to Sedgwick's rule. Another important point is this hydrogen and halogen, they have to be present at an angle of 180 degree. That is, the position should be anti-periplanar. This hydrogen and bromine should be at an angle of 180 degree opposite to each other. It is because this base is negatively charged and this halide ion which is going to depart is also negatively charged. So because negative repel each other, so they would be most stable when they have an angle of 180 degree. So this reaction is an example of beta elimination, alpha beta elimination, or simply beta elimination, or 1,2 elimination, as the hydrogen and halogen is removed from adjacent carbon atoms. So this is the case where we have Sedgwick product as a major product, and in general Sedgwick product is a major product, but there are few cases where Hoffman's product is major. Hoffman's product is less substituted alkene. So when the less substituted alkene is the major product, we are going to consider those cases. So first case is when bulkiness is present either in the substrate or in the base or both. right? So what happens is, this, because its base is bulky, so it would be easier for it to approach less crowded carbon. As we can see here, the beta carbon is this and this and this. This and this is same thing, right? So this is 1 degree while this is 2 degree carbon. So 1 degree is easier to approach, so abstraction of proton is easier from this carbon. That is why the double bond formation between these two carbon atoms is easier, and this will be the major product while this one will be the minor product. So bulkiness favors the abstraction of proton from less crowded carbon. Another case that is very important is if our leaving group is poor. Here our leaving group is halide ion and fluoride is a poor leaving group. So as we can see here is, this fluoride is a poor leaving group. So here the mechanism followed is absolutely different, and this base will abstract the proton from less crowded carbon. Let's see why the base abstract proton from less crowded carbon. Actually, because here the leaving group is poor, so what happens is, as the base will abstract this proton, this bond will break, but this bond making will not occur because this fluoride is a poor leaving group and is not ready to leave carbon readily. So hence it will lead to formation of a carbon ion. So the leaving group will depart, but it will take some more time. Hence this carbon ion will attack these two carbon atoms and this fluoride ion will depart then. So instead of one step, this reaction occurring two steps. This is the first step and this is the second step. Right. So because in this the carbon ion is the intermediate, this is the conjugate base of the substrate. So as I have studied in chapter equilibrium of class 11th, conjugate base and acid differ in a proton. So this and this differ in this proton. So this is the conjugate base of the substrate. Hence this mechanism is called CB, where CB stands for conjugate base. So it is a carbon ion, and the order of stability of carbon ion, as we know, is 1 degree greater than 2 degree greater than 3 degree. 1 degree carbon ion is more stable. Hence the elimination occurs from this carbon, and the double bond formed here would lead to major product, right? So this is 1 degree carbon ion while this is 2 degree carbon ion, and it would be less stable. So the major product corresponds to this intermediate. Next, let us discuss another pathway, that is E1 elimination. So 1 stands for unimolecular here. In this, carbocation is the intermediate. So let's consider this reaction. So how it happens? First of all, the leaving group departs, and this reaction is this step is a slow step. So carbocation generation is a slow step here. So this carbocation, what happens is it leaves the proton with the base and lead to formation of alkene. Hence carbocation is an intermediate, therefore carbocations may undergo rearrangement, and we'll be discussing about carbocation rearrangement in our next video. So because carbocation stability is 3 degree greater than 2 degree greater than 1 degree, hence the order of reactivity of alkyl halides follows the same order. So here it is important. Unlike nucleophilic substitution, both E1 and E2 have same reactivity, 3 degree greater than 2 degree greater than 1 degree. While SN2 involved 1 degree greater than 2 degree greater than 3 degree. So important points here are, how will decide whether E1 mechanism would be followed or E2 mechanism would be followed. So it is obvious that because carbocation is formed, so wherever the carbocation is more stable, in that case E1 elimination would be followed. So 1 degree carbocation is very less stable, therefore 1 degree alkyl halide do not undergo E2 reaction. Yes, they do not undergo E2 reaction, E1 I highlighted. They do not undergo E1 reaction, right? 2 degree and 3 degree can undergo E1 as well as E2. So E2 is favored if high concentration of strong base is present, because rate law involved the concentration of base also. So I just want you to attempt these two questions, although these are a bit typical competitive level questions. But please do attempt these questions. This will lead to eliminations. We have to do dehydrohalogenation. So please draw your expected product, and we'll discuss it in our next video. Thank you.